In this video, we're going to apply what we've learned about product of prime factors in order to work out a good method for working out the highest common factor and lowest common multiple of a pair of numbers. Now, we've learned how to do this already by listing factors and by listing multiples, but this method is much more efficient when we have large numbers. The method is outlined here. We express each of the numbers as its product of prime factors, as we did last time. We needn't use index form. We complete a modified Venn diagram, which sounds really tough, but it's really straightforward. To work out the highest common factor, we multiply the numbers in the intersection. To work out the lowest common multiple, we work out the product of all the numbers in the diagram. Sounds really complicated, but if I show you the example, it should all make sense. So in the example, we want to express 42 and 140 as product of prime factors. So we'll begin with that. So same method as before. Going to divide 42 by 2. 2 is a prime that goes into 42. Circle the 2. Think about primes that go into 21, 3 and 7. So 42 is equal to 2 times 3 times 7. 140, same sort of thing. 2 and 70. 2 and 35. 5 and 7. 140 is equal to 2 times 2 times 5 times 7. I'm now going to draw a modified Venn diagram. So I call this a modified Venn diagram because it's slightly different to other Venn diagrams you'll see later on. And if you've never seen a Venn diagram before, don't worry, it'll be really straightforward. What we do, we write inside the box, we draw two circles. One of them will be for the prime factors of 42, and the other will be for the prime factors of 140. And we can see the circles will overlap, and that's where we'll put the common prime factors. So I'm going to label the left one 42 and the right one 140, no particular reason. And first of all, I'm going to fill in the intersection. To do this, I need to look at the prime factors which occur in both of the prime factorizations. 42 is 2 times 3 times 7, 140 is 2 times 2 times 5 times 7. So I can see straight away that there's 1, 2, which is common to both. I only highlight 1, 2 in each of the products because there's only 1, 2 in both of the products. This second 2 here is not in the 42. There's only a 3 in the 42 expansion, not in the 140. 7 I can see is common to both, so I'm going to highlight that. So there's 1, 2 and 1, 7 common to both. So in the middle of the Venn diagram, or the intersection, I'm going to, the intersection was here, I'm going to write 1, 2 and 1, 7. Now, in the section of the Venn diagram, which is the 42 circle, which does not include the intersection, I'm going to put the 3, because 3 is a factor of 42, but not 140. Similarly, I'm going to put the extra 2 in the 140's expansion and the 5 in the section of the Venn diagram which represents the factors of 140 but not the factors of 42. So that's just going to be here. And there we have it. Now if I were to cover up the 140 section which doesn't include the 42, I have 3 times 2 times 7, which makes 42. I were to do the same with the 42, so if I covered up the 42 circle except for the intersection, I would have 2, 2, 5 and 7, which would make the expansion for 140, so I know that I'm right. To find the highest common factor of the two numbers, I need to work out the product of the numbers in the intersection, because the intersection tells us the common prime factors, and if I multiply them, I get the highest common factor. So here, that's 2 times 7, which is 14. And for the lowest common multiple, I'm going to multiply all of the numbers together in the Venn diagram, which will give me, so let's see, 42, 140. That's going to be 3 times 2. I'm just going to join them up to show you. 3 times 2 times 7 times 2 times 5. 3 times 2 times 7 times 2 times 5, which is 6 times 14 times 5, 6, 14, 5, which is 30 times 14. 14 times 3 is 42, so I get 420. That is the lowest common multiple of 42 and 140, which is a little bit easier than listing, all of the multiples up to 420, at least I think. Here is a practice question for you to try. I'd like you to express 24 and 36 as products of their prime factors and use that and the modified Venn diagram to find the highest common factor and lowest common multiple of the two numbers. And that should not be 356, sorry, that should be 36. Let me cross it out, that should be 36. So please pause the video now, and when you're ready for the answers, press play. Here are the answers. We should have that the highest common factor is 36 and the lowest common multiple is 216. So check your cherry trees against mine to make sure that your factorizations are correct, and then check if your Venn diagram is the same. If it is, you should have the same answers. What do you think is the smallest number I have to multiply 12 by in order to get a square number? Well, if I write out 12 as a product of prime factors, I can see 12 is equal to 2 times 2 times 3. In index form, this is 2 squared times 3. Just keep that in mind. Now, if we think about the 12 times tables, we have 1 12 is 12, 2 12s are 24, 3 12s are 36, and so on. But we know that 36 is equal to 6 times 6. It's a square number, 6 squared. So that means that the smallest number I have to multiply 12 by in order to get a square number is just 3, because 12 times 3 is 36. And if we look at the expansion, in index form, I have 2 squared times 3. If I times this by 3, we should notice that this is going to be 2 squared times 3 times 3, which is 3 squared. And what has happened to the indices? Well, both of the indices are now even. And this leads us to the general rule that a number is a perfect square, another word for square number, if and only if all of its prime factors have even indices when I write it out in index form. So here are some examples. The first number, 2 squared times 3 cubed times 5 squared, is not a square number, because the 3 has an odd power. And I will just show you now using my calculator here. If I work out 2 squared times 3 cubed times 5 squared, if I square root this, I will not get a whole number, which proves that this is not a square number. We can see we don't have a whole number, so the number itself is not a square number. Now, for the second one, I can see I've got 3 to the 4, 2 to the 5, 7 to the power 1. It's definitely not a square number because only the 3 has an even power. They all need to have even powers. The C, that is definitely a square number because all of the indices are even, and I'll just show you if I work out the square root of that number, it will be a whole number, which proves that the number is a square. I get a whole number when I square root, which means that we have a square. Lastly, we can see straight away it's not a square number because the second number in the expansion, the 5, has an odd power. This is a typical exam question. By writing 84 as a product of its prime factors, find the smallest number by which it must be multiplied in order to result in a perfect square. So first of all, if I write 84 as a product of primes, 242, 221, 3 and 7. 84 is equal to 2 squared times 3, which is just 3 to the power 1, times 7 to the power 1. Now, the smallest number I need to multiply by in order to achieve a square number is the number which will make the 3 have an even power and the 7 have an even power. Well, to make the 3 into an even power, I would need to multiply by 3. And then to make the 7 have an even power, I would need to multiply by 7. Because obviously 3 times 3 is 3 squared, 7 times 7 is 7 squared. So in total, I've multiplied by 3 times 7, which is 21. So that means the smallest number I need to multiply 84 by to get a square number is just 21. And I can show that here. If I do 84 multiplied by 21, I get 1,764. If I square root this, I will get a whole number, 42, which proves indeed that my answer was the number which I multiply 84 by to get a square number. And it's the smallest such number. Here are some questions for you to try. Please pause the video now, and when you're ready for the answers, press play. Here are the answers. As you can see, whenever we don't have a number with an even power, we need to multiply by that number. So the first question, we have to multiply by 5, second one by 7, and then the third one by 2 and 97, which has the effect of multiplying by 194. Here are some harder questions for you to try if you want a challenge. Please have a go at the questions, and when you're ready for the answers, press play. Here are the answers. When we square a number, we double the indices. So when we square root a number, we halve the indices. So to get the square roots, we just need to halve the indices and then multiply.